So let's take a look at our conclusions from our air pressure activities that we did in class today. First of all, here's what I need you to do in order to get credit for this assignment. Top of your notebook, label a sheet that says Air Pressure Lab, and as you watch this, you're going to write some conclusions or answer some questions that I present to you. This has got to be done before you come into class the next day. First of all, this thing with crushing the can. Here's the picture of what you did. Let's explain what was going on. So here's a rough diagram. You know, you heated the air and the water in the can, and you know what happened. Hot air rose out of the can because we know hot air rises. You could see it. But what you have done is now you have lowered the amount of air in the can. And you saw that because all the air was coming out of the can. It was coming out the top. Well, so long as it stayed pretty hot, the pressures were the same inside and outside of the can. But we took the can and we immediately flipped it upside down in the water. And we made sure that the opening of the can was under the water level so air couldn't go rushing right in and immediately equalize the pressure. And what we saw happen was twofold, both having to do with air pressure. Now, the less air that is inside of the can isn't hot anymore, and it can't move around and push that much. So the pressure now goes back down lower because the air inside the can got colder because we're sitting on top of cold water. So now the air outside is a higher pressure than what the air is inside, and it crushed the can. You had more pushing outside than you had pushing from the inside. Higher pressure pushes towards the lower pressure. The second thing you might have noticed is when you took the can out of the water, it dripped out a lot of water, even though you didn't put it that far into the water container. Well, here's what happened. Air is pushing down on the surface of the water pretty evenly. But inside of the can, we had a very low pressure area. There wasn't much air to push down on the water. So water got pushed up into the can because there wasn't much air to push against it. So let's talk about the balloon bottle activity where we had two bottles and we were trying to inflate the balloons. Let's take this one first. You notice it's really, really hard. I couldn't get the balloon to inflate. The question is why? Well, there's air inside of this part of the bottle, and that air has pressure, so it pushes against me when I try to force extra air in through the balloon, and hence the balloon won't inflate because I've got pressure from the air that's already in there. Now with this bottle, I was able to blow up the balloon. Now there's still air in here, but we learned that there was a hole in the bottom of this bottle. So when I exerted a pressure on this end, it was able to push the air out of the hole, and I was able to inflate the balloon. Something else that's neat with this is I can use this hole and take air out of this side of the bottle like this. I'm going to put my mouth over the hole. I'm going to suck the air out. By taking air out, I created a lower pressure. Out here in the room, the pressure is now higher and the air pushes into the bottle and inflated the balloon. One more time. Now, as soon as I stop sucking the air out, air rushes back in through the hole and the pressures equalize. What if I blow into this side of the bottle through the little hole? By putting extra air in here, by blowing into it, I created a higher pressure and it actually blew the balloon out this side of the bottle. Now you'll notice the balloon is now deflated because nature will cause those pressures to equalize. So let's look at what happened with the straws in the water bottle. We've got this thing sealed up, and there is air in this part of the bottle, and air exerts a certain amount of pressure. It's the same as the pressure in the room. But what you did was you blew extra air into that space. So by putting the extra air in there, you increased the pressure. Well, that extra pressure pushed down a little bit more in the water, which pushed the water up this straw. In some cases, it even came out the top because you put in a lot of extra air, which increased the pressure so much that you basically made a little fountain. This is why I said gently blow air. Now, this is kind of how a barometer works. So the pressure got higher, and my water in the barometer went further up the straw. Well, if I had little graduations, little markings on that straw, the more lines it goes up, the higher the pressure, which I can then use to measure the pressure, which tells me a lot about what my weather is going to be like. Now, you also sucked air out of the bottle. We put a cap on here. Put a little clip, we folded it over, and we closed up the other straw so air couldn't get in or out. And what you did was you sucked air out, which means the pressure down here got lower. Over here in the straw, there was air. That air has a higher pressure now because you took some air out of the bottle. Well, that higher pressure air now pushes down on the water more, and you should have seen the water level in the straw go down. Once again, this is how a barometer kind of works. If this air pressure goes lower, my water level in the straw goes down because I can see, hey, there's not as much water, not as much air pushing down on my water. My level in the straw dropped. It's the basic concept of how we measure air pressure. Now, the marshmallow in the bottle, this was really, really subtle. If you pushed air into the straw, the marshmallow has air inside of it, and that air has a certain pressure. You made the pressure around the marshmallow become a little bit higher than the air that was inside the marshmallow. So you should have seen the marshmallow kind of squeeze together a little bit. It was very, very subtle. Now, on the other hand, when you took air out of the bottle, the air in the marshmallow now has a higher pressure, and the marshmallow should have expanded a little bit. It was very subtle. It wasn't a real dramatic because we couldn't get that good a seal on the bottle. Now, the egg in the bottle activity. We saw that the egg would not fit into the bottle. I get it. Because there was a pressure out here and a pressure out here that was the same. But then I took some paper and I lit it on fire and I put it into the bottle. Well, fire needs oxygen. Oxygen is part of the air. The oxygen got consumed by the burning paper, which means then there was less air, which means a lower pressure. So now there wasn't as much pushing underneath the egg, and there was a lot more pushing outside on the egg, and hence the egg got pushed into the bottle. The same was true on the birthday candle. When I lit the birthday candle, it consumed some of the oxygen. Well, some of the oxygen gets used up, means there's less air now. So less air meant less pressure. I mean, there's more pressure outside, and there was enough pressure outside to actually push the egg up into the bottle. So at this time, hopefully you have some intelligent conclusions and answers that explain what we saw in these activities. They'll be stamped for a done stamp first thing for the next class period.